The purpose of this video is to take a closer look at logistic regression models so that we can understand better how they function. So if you remember back with linear regression models where our outcome variable y is continuous, we have a structural component to the model, which is this portion here. In this example, it is 10 plus 2x. And what that does is that determines where we place this random number generator, which generates a random number for each person's value of x. And the numbers that it generates have a mean value of 0, and the numbers generated have a normal distribution. So there is a structural component to the model, and there is also a random component. And the structural plus the random component determines the value of y for each individual. But how are we going to structure our model when our outcome variable is binary? It can take a value of yes or no, or for example, it could be COPD and not COPD. In this case, how are we going to structure our model? Well, one thing we can see here is that the way this is drawn is incorrect. These are the y values from our linear regression example, but now we only have two kinds of values, no's and yeses. So one thing we can do is we can represent no's and yeses by moving these data points like this. And so now all of these values down here are equal to no, and this value up here is equal to yes. And so now what we have is we have this random number generator, but it's not really a random number generator anymore. It's a random category generator. And so it's generating a category each time, either no or yes. Let's take a closer look at this random category generator to understand it better. So the way this random category generator works is that it will generate either a yes or no each time. And the way we control how many yeses and nos is by controlling the odds of yes. And so what we need to do is we need to define what the odds are. So let's say, for example, that this random number generator, it generates 3 yeses on average for every no that it generates. And so we have 3 yeses to 1 no. The odds of yes here is the number of yeses divided by the number of no's. So for this kind of random category generator that generates 3 yeses for every no, the odds of a yes is going to be equal to 3. Now, if we had, for example, an odds of 1, that would mean that for every yes, it's also generating 1 no, because 1 over 1 equals 1. So what we would expect is that we would get on average the same number of yeses and the same number of no's from this random category generator. If it has an odds of yes of 1, then the yeses and the no's will be balanced. Whereas if it has an odds of yes of 3, there are going to be 3 yeses for every no. So how are we going to use this idea of a random category generator to build our model here? Well, I'm just going to show you the answer, and this is what it is. The way we do this is that the structural component of the model gives us the natural log of the odds of yes for the random category generator. And I'm not going to go into in this video the reasons why the model has this structure. If you're interested in that level of detail, you can look in any logistic regression textbook, and it will usually describe this in the first or second chapter. All we really want to know here is the structure of the model so that we can use it in our research. Now, the natural log of the odds of a yes is not so intuitive. So it would be nice if we could have the more intuitive odds rather than the natural log of odds. So let's do a little bit of algebraic manipulation so that the structural part of the model is determining the odds of a yes from the random category generator rather than the natural log of the odds of a yes from the random category generator. So here's our function. If we take both sides of the equation and take e to the power of that side of the equation, this is still an equivalency. And if we do this, e to the natural log of the odds of yes is just equal to the odds of yes. And this becomes the same thing. And so now we have the equation for the odds of a yes for the random category generator. It's e to the power of the structural component of our model. So here we can now see our model, and I've put in the numbers here for the structural component of the model here. So when x is equal to 2, this part here equals 0.4, and we're subtracting away a 0.4. So this is e to the 0. So e to the 0 would be, for this one, we would have an odds of, yes, of e to the 0, which is equal to 1. So the odds here are 1 to 1. For this random category generator, we're going to get 1 yes for every no that we get. In this particular instance, it's given us a no. Now, if we go out here to the 8, when x equals 8, when this is equal to 8, this is going to equal 1.6. 0.2 times 8 is 1.6, but you subtract away 0.4, you get 1.2. So the odds of a yes from this random category generator is going to be e to the 1.2. And this is equal to an odds of 3.32. Or another way to say that, this is an odds of 10 to 3. 10 to 3 is approximately 3.32. So this random category generator is going to give us 10 yeses for every 3 no's. And in this particular instance, it gave us a yes. So if we compare linear regression to logistic regression, we can see that they are a little bit different. In linear regression, the y value, the outcome, is actually a number. And the number is determined by a structural component, which is a function of the other variables in our model, and a random component, which is a random number generator that has a mean of 0 and a normal distribution. And these two things added together give us the actual value of the outcome. Now, in a logistic regression, the outcome doesn't have a number. It's a category. Sometimes we use a number to represent the category, like COPD. If they have COPD, we code them as a 1. If they don't have COPD, we code them as a 0. But those aren't really numbers. Those are just placeholders for categories. And so we can think of the categories as yes, no, COPD, no COPD, 1, 0. All of them are categories. They're not really numbers. And here, the random category generator is always responsible for generating the final category of the outcome for each individual in our data set. But the odds of a yes at which the random category generator is set, that is a thing which is determined by the structure of the model, by the variables, the other variables that are in our model. And it's a function, the structural component has the same form in both of these models, as you can see, but it's used differently. In the logistic regression model, the structural component, we take the number that determines and calculate e to that number, and that becomes the odds at which the random category generator is set for each individual in our data set. And you can think that each individual in our data set is going to have a different number here because they're going to have different values for all of the variables in our model. So they might have a different value for this x, for example. And so this number will come out to be something different for each individual in our data set. And so each individual's outcome, either yes or no, is being determined by a different random category generator. So this is the difference between linear regression and logistic regression. So hopefully this will give you more insight into how we are structuring our models to explain the structural components of reality.